Hello class, this is lesson 2.2. Here we learn how to add, subtract, divide, and multiply functions. So a pretty easy section. The only difficulty here is when we think about the domain, and I will get to that shortly. So first I'm going to talk about addition, subtraction, and multiplication because they're the easiest, and then we'll talk about division. It's a little more complicated just because we have a function on the bottom of a fraction. Okay, so let's begin. Let f and g be functions. Right, then f plus g of some variable x is simply, we take the formula for f and we take the formula for g and we add them together, as you may have guessed. Okay, and I will do some examples shortly to clarify. And if we minus the functions, we just put a minus sign here. So I'll do plus and minus in the same line. Okay, now f times g, we just write fg. Some variable x is just, we take the formula for f and we multiply it to the formula of g. Okay, now the domains of f plus g and and f times g are the domain, or let me rephrase that, are the overlap, or we could use the word intersection, mean the same thing, of the domain of f and the domain of g. Okay, so this is sort of the theory behind what we are doing, and now I will do some examples to clarify this idea. Okay, so we'll begin with addition, subtraction, then we'll do an example with multiplication. Okay, so for example, let f of x be some function. We'll give it a formula, say x squared plus 1. G of x will be another function, say, I don't know, 1 minus 2x. Okay, now we will find f plus g and f minus g and their domains. Okay, and I'll leave these as functions of x. So x just means the variable here. Actually, let me modify one of these functions, because the domains are kind of boring in this example. Let me do square root of x here, so we have a more interesting domain to work with. Okay, so I changed the problem a little bit just to make it more interesting and more helpful, hopefully. So one place we can start is we could just list the domains of the original functions. The domain of f, which I'll just write as an abbreviation, DOMF. Okay, that's all real numbers. We're allowed to plug in anything into the formula for f. Hopefully you understand that. We're allowed to plug anything in here. Okay, the domain for g is 0 off to infinity. So as I've said in previous lessons, in this class when we're dealing with variables under a square root, we request that the variable is greater than or equal to 0. Okay, so here's the two domains. Okay, now let's just put that off to the side for now. We'll use this information shortly. Okay, so step 1, let's do f plus g. Okay, maybe I'll do f in green, and I'll do g in red. Okay, f plus g. It's a function of x. So first, we just take the formula for g, which is take the formula for f, it's x squared plus 1. We add that to the formula of g, which is 1 minus, right? And then we just simplify. So these 1's cancel, or no, they do not cancel out, sorry. The 1's add up to 2, so we have 2, so we dealt with these terms. We have an x squared term, and we have negative 2 square root x. Okay, we can't simplify any further, so that is the resulting function when we add those two functions together. Now let's deal with the domain. Now I said earlier the domain was the overlap of the two original domains, so we find the overlap here. Now when you're starting this out, it may help to draw a picture. So here's the domain of f. I'll do that in green. There's the domain of f. Write all numbers from minus infinity to infinity. The domain of g, which I will write underneath, was from 0 off to infinity, right? We had 0. So now we look for the overlap here, right? And as you can see, the overlap is just going to be 0 to infinity. That's 0 to infinity is on this domain, and it's also on this domain. It's the only time those two domains overlap, or the only time they intersect. And therefore the domain of f plus g is 0 to infinity. Okay, now let's look at f minus g. F minus g of x. Well, it's a similar idea. We take the formula for f, we minus out the formula g. Okay, so here we have to be careful with double negatives, the only complication really. So we have 1 minus 1, and then here we have a double negative when we multiply through. So when we clean this up, we are left with x squared plus 2 square root x. And the overlap of these domains is again going to be 0 to infinity. If we just look at the picture I drew earlier, it's when the two domains overlap. I meant to write a minus sign there. Domain of f minus g is 0 to infinity. Okay, so that is an example when we add and subtract functions. Let's now multiply some functions. Let f of x equal 3x plus 1, g of x equal 2x minus 1. Find f times g of x and its domain. Okay, so f times g, first we take f, and then we multiply it by g. Okay, so now we just multiply this out. Hopefully we know how to multiply something like this. What we do is FOIL it out. Right, so we first do this times that. 6x squared. We do this times that. minus 3x. Okay, now we do this times that plus 2x. And lastly, do this times that minus 1. Right, that's called FOILing out if you want to look that up online or something. Okay, now we just simplify. Here we have some common terms, so we have 6x squared plus x minus 1. Okay, now what's the domain? Well, the domain of f was all numbers. The domain of g was also all numbers. So not a very interesting domain. When we take the overlap of these, it's going to be all numbers because they happen to be the exact same thing to begin with. Okay. Now that we know how to add, subtract, and multiply functions, let's look at an example when we plug numbers into the sum, difference, or product of functions. So let f of x equal square root x, g of x equal, I don't know, 3. Let's find f plus g of 1, f plus g negative 1, f minus g of 2, f times g of 3. And I'll explain what these symbols mean. So if we do f plus g of x, we know we just add the two functions together. Now when I wrote f plus g of 1, what this means is we just plug in a 1 for x. So we plug in x equals 1. Right, so we get square root of 1 plus 3, 1 plus 3, 4. Okay, so we did this one. If we do f plus g of negative 1, what's that? Well, let's try plugging in a negative 1. But uh-oh, look what happened here. Now we had the negative under the square root, which I just said we do not allow when we're dealing with functions in this class. So what happened here? Well, what happened is we plugged in a number that's not in the domain. And that's simply because the domain of here is greater than or equal to 0. Domain here, we could plug in anything there. So we put a number that's not in the domain, right? It's kind of a trick question. So I could say the answer does not exist for this one. Okay. Now what's next? F minus g of 2. If we do f minus g, plug in the number 2, that means we do square root x plus g, and we evaluate this when we plug in a 2, right? So that's square root 2 plus 3. Okay, lastly we have f times g of 3, f times g of 3. F times g is this, and we're going to plug in an x equals 3. So we get square root 3 times 3. It's a little more pretty to write the 3 out front. And there we have it. Okay, so to summarize, we learned how to add and subtract and multiply functions, and we also learned how to plug numbers in. Okay, so now let's turn our attention to division, which is pretty much the same idea. There's just one extra complication, and that's if we have a function on the bottom, it cannot equal 0 because we cannot divide by 0. Right, so So if f, g are functions, then f over g of x, simply we put the formula for f on top, formula for g on bottom, but we have to add one extra condition. So we have to have it be provided that the bottom never equals 0. So we have an extra condition here. Okay, now the domain of f over g is again the overlap or the intersection of the domain of f and the domain of g, and also we need to request that g of x does not equal 0. So we exclude the x values where g of x would be 0. Right, because we cannot plug any x values in that would make the bottom 0. So we just have one extra condition when we use division. Okay, so I will do an example now. So let's have f be the formula x plus 2, g be the formula, I don't know, 2x minus 1. Now notice the domain of f is all numbers, the domain of g is all numbers. So the overlap of these domains, sometimes we use this symbol for overlap, it's the intersection symbol. So the overlap of these domains is all numbers. However, when we do f divided by g, we do the f on top, the g on bottom. So now we add the extra condition that the bottom can never equal 0. So now we have an extra condition. Right, so if I simplify this condition, that's 2x can never equal 1, x can never equal 1/2. Right, because if I plugged in 1/2 here on the bottom, we'd get 0 on the bottom, and that's not allowed, it's undefined. Right, so here we found f over g, and the domain of f over g is now all the numbers, but we have to exclude 1/2. Right, so let me draw a number line here. Here's the number 1/2. So we could be all the numbers less, then we jump over 1/2. Right, so from minus infinity to open 1/2, we could plug those numbers in, but then we have to jump over 1/2. Right, so this is the domain. It's the overlap of the domain of f and the domain of g, plus the extra condition that the bottom function g can never equal 0. Okay, so let me do one more example. Let's take f of x to be the square root of x plus 1, g of x to be the square root of I don't know, x minus 3. Okay, find f over g of x and its domain. So first I'll start with the domains. Okay, what is the domain of f? Well, we have to take the variables under the square root and make it greater than 0. So it's x plus 1 greater than 0, right? which is to say that x is greater than or equal to -1. So if I put that in interval notation, -1 to infinity, right, the domain of G is the set of values where x minus 3 greater than or equal to 0, right, which is when x is greater than 3, or in interval notation is 3 off to infinity. So the overlap of these, which we can use the intersection symbol, the overlap of these domains is what? Well, I'll draw a picture here. Here's the domain of f in green. It's -1 off to infinity. Right, that's -1 to infinity. And in red, I'll do the domain of G, which is the number 3 off to infinity, right? 3 to infinity. So what's the overlap? Well, this is the overlap. 3 to infinity is the overlap. Right, 3 to infinity is included in both of these pictures. So that's the overlap. Okay. So if we did f over g of x now, we do f on top, which was square root x plus 1, g on bottom. And now we also have an extra condition that the bottom cannot equal 0, right? So when does the bottom equal 0? This only equals 0 when x is 3, right? If we plugged in a 3, this would equal 0. So what we're going to have to do here is we are not going to allow the number 3 anymore, because that would make the bottom 0. Okay, so the domain of f over g is the overlap of f and g with the extra condition that we cannot have 0 on the bottom. The only time we have 0 on the bottom is if we plug in 3, so now I'm going to have to do an open parenthesis around 3, because we cannot plug in a 3 when we put g on the bottom of the function. Okay, so that is that is the domain of f over g. Okay. So the last example here is sort of we do everything we've learned in once. It's something called a difference quotient. And it's an idea that's important in Calculus 1, but it does mention this in the book here, even though most of you will not go on to calculus, but still an important idea. So what we do in the difference quotient is we have a function f, right? F's a function, and the difference quotient is we plug in an x plus h into the function, and then we minus out the original function. So that's just the difference of two functions, what we did earlier. We take the formula for this, minus the formula of that. Okay. And now we divide the result just by a number h, and that's the difference quotient. So I'll just do a quick example here. Let's have f of x be 2x, right? Find the difference quotient. Okay, well, if we were to plug in x plus h into this function, that's 2, and then we plug in x plus h into the input. Okay, so we get 2x plus 2h. Okay, so now we're ready to plug in. We'll plug in 2x plus 2h here. So if we do f of x plus h, we minus out f of x, divide everything by h, we get the following. I'll do this portion in red. That was 2x plus 2h. Now we minus out the original function, 2x, and we divide everything by h. Now we can simplify a little. These cancel out. We have 2h over h. And the h's cancel out, and we just have 2. Okay. So if you're interested, the importance of this is this actually tells us the rate of change of the function f. So if f was describing, say, the movement of an object, like the movement of a car in space, then after we plug into this, this sort of describes the speed, right? So it's a concept one would learn in Calculus 1. It's sort of the way of finding the speed of a function, roughly speaking. But anyways, you have all the tools to do this stuff, so that's sort of why they put it in the book. Even if you are not moving on to calculus, it's still an interesting idea. Anyways, that's all I have for today.